Hey, 8th grade. So today we're going to start talking about speed and velocity. So yesterday we kind of touched on this idea of speed, and our main question for today is how do I calculate speed? So like we talked about yesterday, speed is distance over time. And you know this because we looked at those graphs that had distance on the y-axis and time on the x. So if you divide distance by the amount of time it took, it tells you the speed that the object was moving. So we also talked about this thing called a speed triangle, and this was a way to manipulate this equation without having to remember all of the equations. So we put distance in the top and then speed and time in the bottom. And if you were to go across the bottom, you know it's multiplication. If you have the two variables, one over the other, it signifies division. So when we talk about speed and we talk about slope, if you see acceleration happening, this means we all have a positive slope and we're going up the hill. And negative acceleration or deceleration would be a negative slope, like going down the hill. And anytime on a graph that you see a constant speed, which means that the speed actually isn't changing, you'll notice that there's no slope or a horizontal line. So when we talk about rate of change, we're talking about the rate of the velocity or the speed over the amount of time it took to get there. So the steeper the line, the steeper the slope, and the faster the change in the rate. And this is very similar to what we talked about in math, with the rate of change increasing as the slope gets steeper. Today we're going to introduce this new term called velocity. And velocity is the same as speed, but with a direction added in. So it's a lot more descriptive of a word than speed, and it should be used whenever possible. So instead of saying that you're traveling 60 miles an hour, you might say I'm traveling 60 miles per hour north, and that would be a velocity. So like we talked about, we have this velocity up the y, time across the bottom, and you have constant acceleration shown when the slope doesn't change, constant velocity where we just stay at this 8 meters per second, and constant deceleration. So instead of this side being distance, now we're talking about this side being velocity or speed. So this is what we talked about yesterday with this distance versus time, where you have the faster steady speed. If it's kind of swooped, we have that getting faster acceleration. Steady speed if the rate of change is the same. A stationary object, and then this last one returning to start because this is showing distance. Unlike when we talk about velocity on the side, where this is actually just showing acceleration and deceleration because the speed or the velocity is now what you're measuring on that y-axis. Go ahead and move on to your worksheet for today and then your exit ticket.